vPC with fabric pairing. Hello, this is NetMaven. To avoid the usage of vPC physical peer link, a vPC fabric peer link can be used, which provides an enhanced dual homing access solution without the overhead of wasting physical port for vPC pair links. So this feature preserves all the characteristics of a traditional vPC. Being the traditional, we would like to have a peer link in between the leaves, but we don't connect the leaves in VXLAN, EVPN fabric. So an advantage of leaf and spine technologies and the ECMP equal custom multipath between any two leaves can be used also with vPC fabric peeling, with all spines now sharing VXLAN EVPN leaf to leaf and east to west communication and the vPC fabric peeling. The overall use of provisioned bandwidth becomes more optimized. Given that all links are shared, the increased resiliency for vPC peer link is equal to the resilience of the leaf. Is it like the equal path? To leaf, and the path goes to here. This is a significant increase compared to two physical direct link between the vPC, between the vPC members. We don't need this anymore. So the vPC peer keep alive can be over the spine infrastructure in a parallel to the fabric virtual peer link, and as an alternative to increase the resiliency, the vPC peer keep alive can still be deployed over out-of-band management network or any other routed network of choice between the vPC member nodes. In this lab, we're going to configure the vPC pair using the physical peer link, which is not a good way. Instead, we're going to use vPC, the fabric peer link. Okay, so vPC fabric peer link provides an enhanced dual homing without the overhead of wasting your physical links for vPC peer link. So we're preserving all the characteristics of a traditional vPC. The vPC pair fabric link reachability occurs via the routed network over the spines. So the communication between the vPC member switches uses the VXLAN encapsulation. So it's VXLAN peer link over the fabric. So I will migrate the vPC configuration from the physical peer link to fabric peer link in this topology. What we will have to choose is my VXLAN EVPN fabric site in fabric controller, and we're going to choose a vPC pairing. There's a checkbox to use virtual peer link. We're going to pick this leaf 2. Use the virtual peer link, click save, click OK. Now let's click action, recalculate and deploy. We now deploy the whole configuration. Let's close that up. Close my fabric. Go to topology. Click my fabric. Check configuration. Now you see the peer link we have supposed to use is the 1/3, 1/4. They're not in use between. Instead, we're using a peer fabric, fabric peer link. Log into leaf 1 and show run interface E1/3, E1/4. We don't see anything for the peer link. Let's show vPC. I see you have peer link over port channel 500. Want to show you is show ROM BGP. Look at here, we advertise PIP. So what does that mean? So there, one additional command added is advertise PIP. The other is on the vPC enabled leaf, all layer 3 routes are advertised by default with the secondary IP address, which is a VIP of the leaf switch VTAP as a BGP next hop address. The prefixed routes and leaf generated routes are not synchronized between the vPC leaf switches. Using the VIP as the BGP next hop for these types of routes can cause traffic to be forwarded to a wrong vPC leaf or border leaf and black hole. So the advertised PIP, primary IP, cause the primary IP to be advertised as the next hop when propagating routes in the BGP. So this ensures that the traffic is always forwarded to appropriate leaf. So this functionality can be used in the physical peer link scenario, but is especially important for a virtual peer link. So due to the peer link bandwidth consideration. Next is show run vPC. In the show run vPC, we can see here is a virtual peer link showed up the destination and the source. The NDFC value is 56 over the fabric. Port channel for the peer link is replaced by virtual peer link, this feature. Configured using an IP of the loopback 0 interface. Show run interface loopback 0. Source is defined as a loopback 0. So that's used for IGP and BGP pairing purposes. Next different thing is show run MVE. Show run interface MVE 1. Here you go. And if we see there's additional command added is advertise virtual RMAC. What is advertise virtual RMAC? This command calls the vMAC address, virtual MAC, to be used with the VIP and system MAC to be caused by the PIP. So when we advertise PIP, also advertise virtual RMAC commands enabled, there are the type 5 routes advertised with the PIP, and type 2 routes are still advertised with the PIP. So the advertised PIP and advertised virtual RMAC commands must be used together. If I enable one or not enable other, the configuration is considered invalid. And logging to leaf 2, we can verify the same command also being used. Interface E13 is not being used for the peer link, and show run BGP. We will see a command advanced PIP is added. Show run vPC, and here is my peer link. Show run interface loopback 0. And in this case, the destination will be leaf 1, source is my leaf 2, so on loopback 0 interface. Show run interface and VE1. I have advertised virtual RMAC also. In the next thing I would talk about is the vPC fabric peer link is established over the transport network, which is the spine of the layer of the fabric. If you take a look here, my vPC link is established over the spine layer. As a communication between the vPC peers occur in this manner, so the control plane information CFS messages that is used to synchronize the port status information. So VLAN has a VLAN information, as a VLAN to VNI information, mapping information. We have a host MAC information, address are all transmitted over the CFS, over the fabric, okay. CFS messages are marked with appropriate DSCP value, which should be protected in the transport network. You will argue, what is marked of the CFS message? Is marked as D, if you know QS is marked as DSCP 56. I can show you, show run. You might see it already, right? Show run vPC. Here you go. It's marked, this virtual peer link is marked as a DSCP 56, but we have no any QS policy map. We don't have policy map, we don't have class map to match it, and we don't know whether it's applied. It should be applied to my fabric interface. Fabric is 1.1 and 1.2, also on the spine also. So where do I enable this QS to support my CFS messages? Go to fabric, click my fabric, edit this fabric. Under fabric vPC, we click vPC advanced PIP, which is good. And scroll down, we'll have to say enable QS for fabric vPC peering. Okay, this is the policy name, automatically generated. That's fine. Now click save. Okay, it asks me to recalculate deploy. As what I said, the CFS message will be transported over the spine layer. You will see the configuration applied to my spine and spine interface in the inbound manner. Deploy all. Now you will see they close this page. After QS gets deployed, we can go to my spine 1 and show run as class map. If I show class map, show run, Here you go. I can find class map is trying to match DHCP 56, which is my default value. Show run vPC as a mark for virtual peer link 56, and we have a policy. Look here, policy map. This is to set the traffic to QS group that corresponds to the strict QS queue for appropriate spine switch. In this example, the switch sends traffic to QS group 7, which corresponds to strict priority queue QS 7. So this Q7, we'll see that different Cisco and Nexus platforms may have different queuing structure, but here is QS group. So class map, there you go. Show policy map, which is a priority queue. Sure, again. Assign, then we'll have to assign. Close that, or take a look at the diagram. My topology is better. In this case, I have assigned this to E, so now 1 and 1 and 1 and 2. Show run interface E1 and 1 and 1 and 2. The policy map has a classification service policy to orbit interface towards, here, towards the vTabs, which is my leaf layer. Lastly, let's do some verification, the vPC peer configuration. So to show the status of vPC fabric peering configuration, we could do is show vPC fabric ports. We don't have other vPCs, but the vPC fabric ports is my 1/1 and 1/2 on both leaf 1 and leaf 2 also. Fabric ports, and show vPC. This we can tell virtual peer link mode is enabled. Say on vPC leaf 1, vPC virtual peer link mode is enabled. Also, there's a very good way to check the vPC peer link VLAN consistency. Show vPC virtual peer link VLAN consistency. See, we don't find any inconsistency here, and vPC virtual peer link is working.